Applications. The normal distribution can be found or used, to solve many practical problems. Example 30, the time taken to complete a logical reasoning task is normally distributed with a mean of 55 seconds, so mean of 55, and a standard deviation of 8 seconds. Find the probability correct to 4 decimal places that a randomly chosen person will take less than 50 seconds to complete the task. So, I'm going to write down my values that I know. Mu equals to 55 and sigma. Oh, okay, that's not coming off. Sigma equals to 8 seconds. There we go. The probability that x is less than 50 is approximately what? So, I'll grab my calculator. The probability that x is less than 50, I'm going to use my interactive distribution, continuous normal CDF. Lower than, the lower bound would be 0, because of course it makes sense that we can't have less than 0 seconds. The upper bound, it would be 50, because we're saying less than 50 seconds. Standard deviation is 8, and our mean is 55. 0.2660. 0.2660. Find the probability that a randomly chosen person that will take less than 50 seconds, so less than 50 seconds, to complete the task if it is known that or given that this person took less than 60 seconds. So that would be the probability that x is less than 50, given that x is less than 60, equals to the probability of that overlap, which is just x is less than 50, over the probability of x being less than 60. I think we know how to do this. I'm just going to write the answer. You can double check it in your own time. 0.3624. Limits of acceptability imposed on the length of a certain batch of metal rods are 1.925 and 2.075 centimeters. It is observed that on average 5% are rejected as undersized and 5% rejected as oversized. Assuming that the lengths are normally distributed, find the mean standard deviation of the distribution. Again, graph makes it so much easier. So the mean, of course, is 2. Oh, sorry. I haven't revealed that yet. We don't know the mean is 2 yet. We don't know what the mean is yet. We know this value up here is going to be 2.075, and we know this value down here is going to be 1.925 centimeters. I should add that in just for clarity's sake. The middle is going to be our mu, which we don't know yet. We don't know what the mean is yet. We know that this section is going to be 5%. We know that this one's going to be 5% as well, which of course makes sense. The middle is now 90%. Okay, we need to find the mean and the standard deviation. Let's start with the mean. The mean is really easy. If the two values on each end are going to be 1.925 and 2.075, and they're both going to be 5% under and over, well, it makes sense that mean is the median, right? Mean is median, median is mode, etc., with a normal distribution. So therefore, our mu equals to 1.925 plus 2.075 over 2, which equals 2. Et voila, we can replace that with a 2 now. Let's keep going. Remembering that z equals to x minus mu over sigma, that's a formula that we should know. We know that z, and I'm just going to pick one of them, right? I'm going to pick, oh geez, what's happened? There we go. I know that z equals to, now I'm going to replace the values in, right? Because, well, 5%, if that's 90%, let's use our calculator for this, right? I know that interactive distribution, inverse normal, right? If I put the tail setting as left, I put in my probability 0.05, well, I don't know what my sigma is. I know what my mean is. I don't know what my sigma is. Right? I can't really just leave it as 1. So I'm going to use the formula. I know that z equals to 2.075 minus our 2 over sigma. This one right here Is there a way that we can find what the z value for this would be? Alright, the trick with this question is we need to form well, just like I was saying earlier, you form an equation that we can solve using the inverse normal function. So as I put in the calculator, you can't use 0.05 and then use 1 in standard deviation. You also can't put x, otherwise it'll give you your some wrong argument type. So we have to put in a number for our standard deviation, even though we don't know it. We know the mean is 2, but if I wanted to find the standardized score, well, that's just based on the normal distribution, which would give me a normal mean of 0. There we go, 0, and a standard deviation of 1. Now, what does this mean? This means that in order for me to get from the left-hand side to 5% of my data, or 0.05, in my normal distribution, that's negative 1.644 standard deviations. So this right here is, and I'm going to approximate it as negative 1.64 standard deviation. I don't have to do the right-hand side. I can if I want to, but I know that's just going to be 1.64 standard deviation because that's on the right-hand side. Right 50% of data, right 5% of data, sorry. Well, now I can solve the rest of my equation. Let's keep with this formula that I was using earlier, not formula, sorry, equation I was using earlier, and use the 1.64. So I'm going to say that equals 1.64. I know the standardized score. It's 1.64. Therefore, when I solve that, sigma becomes 0.0456. I'm just approximating that again, so I use approximate. Any questions about that? Okay. If you think about it this way, this is the normal distribution that we've got for this. It's normally distributed. But if I take out those values and I just focus on the fact that, well, 5% of the data is negative 1.64, etc., standard deviations, where I can apply that, kind of lay it on top to see what that value would be equal to and solve for my standard deviation. Questions? I put in the inverse norm of CDF, the left-hand side being 0.05, with a standard deviation of 1 and a mean of 0. So our normal, our standard, I'm using the wrong words here, our usual normal distribution of 1 and 0 for those values. Of course, if you wanted to put the right-hand side, and you go right and put in 0.95, that will give you the same answer. Oh, the same answer as well. Okay, let's continue. Last page, normal application to binomial distribution. This is the general proof I was talking about earlier about why, etc., is true. Now, in fact, they look very like a normal distribution as you increase the values. As you increase your values of your normal, of your sample size, sorry, you'll end up with a graph that just looks more and more like your, like your bell curve, right? Your normal distribution. Just as a side note, I'd like you to copy down this general rule of thumb. A general rule of thumb. Generally speaking, a sample size is large enough if n times p, or sample size multiplied by probability, is, and also your sample size multiplied by 1 minus your probability are both greater than 5. That is fine. We can replace a binomial distribution with a normal distribution when the sample size is large enough. Right? It makes sense that your height, for example, that's height's a bad example. Let's say shoe size. Shoe size is a binomial, right? However, if it's large enough sample size, we can replace this as a poor word for it, perhaps model that binomial distribution with our normal distribution. We can use the mean and standard deviation using this formula here. NP is our mu, or our mean, and our NP times 1 over 1 minus P, or square rooted, is our sigma. Looking at this example here, a sample of 1,000 people from a certain city were asked to indicate whether or not they were in favor of construction of a new freeway. It's known that 30% of people are in favor. Find the approximate probability that between 270 and 330 people in the sample were in favor of the new freeway. I'm going to go ahead and define my values first. Let x variables first, sorry. Let x equal to the number of people in sample in favor. I'm going to define my n equals to 1000 and my p equals to 0.3. It makes sense that following the formulas, I know that 300 is going to be my average, and my sigma, or my standard deviation, is going to be the square root of 1000 multiplied by 0.3 times by 0.7, which gives you a square root of 210. Okay, let's do some actual math. We're trying to find the probability that's between 220. Probability that it's going to be between 270 and 330. Now, by our logic, this is going to be the same as saying from that certain standard deviation to another, but we'll focus on that section later. To get our value for the probability that someone is between these two, what we can do is we can go to the calculator. You're going to go interactive, distribution, normal distribution. We're going to put in our values. Okay, I'm going to put in our values of 270, that's my lower. My upper is going to be 330. My standard deviation is the square root of 210. Where's my keyboard? There it is. 210. And my, don't forget to close the bracket. And my mu is going to be 300. There you go. 0.9615, etc. I'm just going to round it off as approximately 0.9616. There's another note before we finish it off. That is the same as, I should probably rewrite that here. These are the same if you write equals probability of 270 minus 300. I'm going to need a little bit more space, apologies. Let's try that again. Probability as 270 minus 300 over square root of 210 is less than our standard deviation, or standard value, sorry, standardized score, 330 minus 300 over the square root of 210. Okay, and when we put that in the calculator, when we put this into the calculator, we can get the same answer if and only if we use our mean as 0 and our standard deviation as 1. So they're the same, right? So I can then put in my calculator, interactive. I can put in distribution, continuous, normal CDF. I put in my lower bound as, and I'm not going to bother typing that out. I'm going to type it out in my main instead of that weird box. So I'm going to put in my calculator. I'm going to go fraction 270 minus 300 over the square root of 210. And I'm just going to copy that. Right, because I don't want to have to type this complicated fraction into that box. So I'm going to copy that, interactive, go again, distribution, continuous, normal CDF, put that in. I'm going to copy and paste into my upper one as well, but change my values because now it's going to be, because it's still going to be, 330 minus 300. It's just going to be the x value subtracting the average, isn't it? And then I'd leave that normal, and that will give me the same answer. Okay, so those two are the same.